Hi, this is Shakil Ahmed. In this tutorial, we will obtain the odds ratio when we have a survey weighted data. We will find the odds ratio using without adjusting the covariates and adjusting the covariates and including interaction terms. And we will also see how we can find the odds ratio for a subgroup of data using survey design function. So here we have the survey design function as we obtained the survey design function from the weight and the primary sampling unit and the stratification variable from National Health and Nutrition Examination Survey 2005 to 2018. And these are the design information, and we have data on all these variables. You can see just attached data, and then we will find the association between income that is on a categorical scale, high income versus lower income, and the chronic condition that is also a binary variable, have some chronic condition or not. So we are just fitting it logistic regression using surveyglm command, and then we get the summary. And on the basis of these estimates, this will give the estimates corresponding to log odds uh, as the dependent variable, and the exposure, that is income, as axis. So it will give the uh, change in uh, log odds when one unit change in x. Basically, we can say that if we are setting one for male and two for female, then we can say that there is a low chance of having chronic condition in women as compared to men. And then we can exponentiate it coefficients and the confidence intervals. That would be the odd ratio and corresponding confidence interval that we get in this format. And then uh, we run the command uh, to combine the odds ratios with the p-value we obtain here. Basically, we just get the p-values corresponding to each coefficient in this column like this, and we can just extract this column using uh, summary fit one. That is, this is summary fit one, and uh, from this we are selecting this column basically. A probability of t is greater than absolute t. Absolute, that is basically the calculated value of the t statistic. So we get the p value. So let's see how we can do these analysis in R. We have again the data I have already uh, extracted and cleaned the data, so we don't uh, waste much time on data cleaning. And we will just get the association between the odds ratio for unweighted analysis using the GLM command, simple. And when we have the weighted data, then we need to use svyglm, that is survey weighted, and that is used for survey weighted data. So let's start for survey weighted data. We again obtain the survey design object, and we have data already attached, and we are basically running a simple model that is I'm just running on, for example, income without including other variables. That is, income is as exposure and outcome is the chronic condition. So we are checking whether income has some impact on chronic condition or not. So we will get the odds ratio For this is giving just a warning. If we have any observation with zero weight, that would be not included in and dispersion calculation. So this is summary fit, as we already discussed in outcome in our file, and we have estimates, that is basically the effect of change in income, effect of 1 unit change in income on change in log odds. And odds is basically the probability of having a disease divided by probability of not having a disease. So you can see we can exponentiate these coefficients, and we will get the odds ratio, and the interpretation is already we have discussed. If this is greater than 1, we can say this group have higher chance than the reference group. Here the reference group is low income. We have three categories of income: low income, high income, and don't know. So we are comparing the high income group with the low income group. That is 0.8. It means the people with high income have a lower chance of having a chronic condition than those with low income. So this is the confidence interval. 95% confidence interval we obtained, and we can write all these in form of a data frame for easy uh, to present, making it easy to present. That is, we have exponential coefficient and confidence interval, and then I am extracting the p-value from this uh, analysis. The most right column of the summary coefficients. So you can just run this, and we will find the data D1. So this is the odd ratios and 95% confidence interval, lower confidence limit and upper confidence limit, and the p-value. So this is the result. You just copy, or you can just save using the write.csv command. When you have a lot of variables, then there will be a large table, and you can just save to Excel, and you can just present in your articles. So this is the more convenient way to report your result. You don't need to copy paste one by one, but you need to do some working. I have just first make a data frame, and then I name the columns. The first column is OR, odds ratio, and the second column is 95% lower confidence limit, and third column is 95% upper confidence limit, and the last column is the p-value. And then now we are adjusting for covariates. Adjusting for covariates is necessary when we have imbalanced data. For example, uh, the effect of income on chronic condition is dependent on age. For example, in higher age, people with higher age, there is a higher chance of, there is a higher effect of income on chronic condition, and for people with low age, for example, 30 to 40, there is a low chance, or there is a less a strong relationship between income and chronic condition. So we can adjust this effect in our analysis using the including age as the covariate. Similarly, I am also balancing the data on the basis of sex, and you can also include other covariates, like we can include the physical activity, or people having diabetes, or the BMI. We can also include all these demographic or clinical variables in as covariates to make the association. Uh, the mediating role of these variable between income and chronic, you can say confounding effect of these variables. Basically, these effects are confounded between the income and chronic condition. So you can use you can include all those variables that are causing confounding uh, in your analysis to avoid the spoiled or the biased effect of income on chronic condition. So I'm just including income and age as covariates, and we can see the summary. And you can just compare the two odds ratio, how the odds ratio is changing. For example, I will just obtain the final table, and you can see that now the coefficient for higher income is 0.74, although it was zero point 0.8 in our analysis. 0.74. Uh, we now getting 0.749, and previously it was 0.804. So it is now reduced due to inclusion of age and sex in our analysis as covariates. So this is the true effect. Basically, we are adjusting for covariates, and in such type of analysis where these variables, these demographic variables, are more prone to have a confounding effect on the relationship between income and between exposure and outcome, then you need to include these variables in your analysis. Similarly, you can also check the interaction effect between these variables. Basically, we are using just age as a variable, but age may have an interaction effect uh, uh, on of income on chronic condition. Basically, income and age is interacting, uh, has an interaction effect on the chronic condition. So we can just check this, and we can get the final result for odds ratios. So you can see the income and uh, the interaction between income, a higher income is now increased to zero point 0.9 due to inclusion of the interaction effect, but there is no significant, the uh, age and income is not much significant. As you can see, the p values are larger, that is 0.15 for age and income interaction, and sex and income interaction it is 0.09. So this is not much significant, so we can just ignore these interactions while doing our analysis. And if the interactions are significant, then you need to do a subgroup analysis. For example, if age has an interaction, then you can see the subgroup, the effect of income on income on chronic condition for the for different subgroups of age. For example, we can see what effect of how income is affecting the chronic condition status in elder population and in younger population. So you need to conduct a subset analysis. So for subset analysis, we need to convert the survey design with the condition. We need to uh, basically we are imposing a restriction on age to get a subpopulation. That is, we are selecting only individuals with age greater than only adults. Basically, you can write just 18 to select the adult population, as there is no role of income in younger ones basically. So we are just see the relationship between income and chronic condition in elder population. So I'm just putting the condition age is greater than 20, and we get the design object now as subset 1 instead of survey design. So you can just run, and we can again fitting a model with income only, but dividing as for the sub population. So you can just run this command, and now you can see how income is affecting chronic condition. Now it is again 0.766. So it is clear that when we check the interaction of income and age on the chronic condition, that was not significant. So you can see the result is not much changed. It was 0.80 when we included all data set, and when we exclude the people with individuals with age less than 20. So the effect of income, the odds ratio of low income to high income is again 0.76, that is near to zero point 0.8. So this is all about the odds ratio when we have survey weighted data.